So welcome to Electronics 6 Lab. We are watching signal system lecture series. Today the topic of discussion is the continuous time versus the discrete time signals. Okay. So when a signal is specified for all values of t, okay, all values of time, that is the continuous time signal. Okay. When the signal is specified at integer values of time, that is the discrete time signal. For example, a voice signal recorded by a microphone. Okay. This is the example a continuous time signal. Similarly, if we measure the temperature continuously over a uh, time of the day. Okay, so that is the continuous time signal. Okay, so taking the temperature exactly at one time, that is the discrete time signal. Or when we take the photograph, that is the discrete time signal. Okay, so closing the stocks market every day, that is the discrete time signal. So these are some examples of continuous time and discrete time signals. Okay, so let us see in the details what is the difference between the continuous time and discrete time signals. Okay. So, continuous time signal, as I mentioned, the continuous time signal, that is the one in which the value exists at every instant of time. Okay, so we have a value at every instant of time. Okay, so this is the continuous time signal. Similarly, discrete time signal, we have the value defined at the discrete instant of time. Okay, uh, so continuous time signals are typically represented by the mathematical functions like sine and cosine waves. Okay, and discrete time signals are specified by the sequence of numbers. Okay, so basically continuous time signal. So this is the continuous time signal. So you can see this is the typical sine wave, and this is the over the time axis. So the value is defined for every possible values of the time period. Okay, that is the meaning of the continuous time signal. Okay, so we have a value at every instant of time. Okay, so this is the continuous time signal. The discrete time signal, so it is a sequence of number. So these are the sequence of numbers. So this is the example of discrete time signal. So we are not taking the value at every instant of time, we are taking at discrete instant of time. That is the meaning of the discrete time signals. Okay. So continuous time signals are that is the analyzed by the using of continuous time domains technique. That is by the help of Laplace transform and Fourier transform. Similarly, the discrete time signals are analyzed by the discrete domain signal, that is a Z transform and discrete Fourier transform. Okay, so one is analyzed by the Laplace transform and Fourier transform, and discrete time signals are analyzed by the Z transform and discrete Fourier transform. Okay. Now the continuous time signal actually have the infinite bandwidth. Okay, and the discrete time signal have some finite bandwidth. Okay. So as the continuous time signal we are taking at every instant of time. So that is why it is the infinite bandwidth. Okay. In discrete time signals, what we are taking at some interval of time, or there is a discrete interval of time. That is why it is a finite bandwidth. Okay. So it is the signals are continuous time signals are denoted as x of t, where the discrete time signal are denoted as x of n, where n is an integer. Okay. So these continuous time signals are described by the differential equations. Okay, and the discrete time signals are described by the difference equation. So differential equation means so it is the dy of dt, that is the plus suppose 10y of t plus 5 equal to some x of t. So this is the example of a differential equation. So difference equation means it is described in the form of the n. So y of n minus 3 y of n minus 1 suppose plus that is the 4y of n minus 2 is equal to x of n. So this is the example of a difference equation. Okay. So differential equation we have in the continuous time signal, and in the discrete time signal we have the difference equations are there. Okay. Next is so continuous time signal have the more in number of information. It we have the value is defined for every instant of time. That is why the continuous time signals have the more information, and discrete time signals have the less number of information. Okay. So it has the more memory. It requires the more memory. The continuous time signals are require more memory, and discrete time signal requires the less memory. Okay. So this is the examples of the means continuous time signal. So in this case, the value there is a value at every instant of time. So you can see the value is there at every instant of time. Okay. So this is a typical example of a sine wave. Okay. So it is the signal is represented by the x of t. Okay. So x of t I can write as the, suppose the amplitude is some a. Okay. So a is the amplitude. So it will be a sine theta or omega t. Okay. This is a typical level or some phi phase is there. So it is phi. So this is examples of a typical continuous time signal. So discrete time signal, as I have told you, it is represented by x of n. Okay. So these are the values of n. Okay. These are the values of n. So it is a finite duration signal. So x of n I can write as, okay, x of n is so at 0 the value is your 2. So at that instant time instant 0, it has the value of 2. Similarly at 1 the value is 3. Then at 2 the value is 2, and at 3 the value is 3. Okay, 3, and at 4 the value is 2. Okay, so this is our the discrete time signal. So this is actually 5 point sequence. Okay, 5 point sequence that we'll see in the coming classes. Okay, and there is a reference is your, it is starting from the 0. Okay, that is 0 is taken as a reference. Okay, so it is denoted by the arrow mark. Okay, so this is the example of a discrete time signal. Okay, so that is the differences between the discrete time signal and the continuous time signal. Okay, so the continuous time signals are represented by the typically sine wave, and discrete time signals are represented by the sequence of the digits. Okay, so that's the differences between these two signals. Okay, so thank you for watching this video. Okay, so if you have any doubt, you can free to ask me in the comment section. So thank you all. So have a nice day.